Alright, so to have a look at this page 52 here, so we've got talking about the probability of rolling a 6 with a die. So P is our probability, N is the number of times the event happens, and X is kind of what we're seeing will happen, or the number that we're interested in. So in this case, our P for this case of throwing a 6 is 1/6. If a die is thrown 10 times, so the number is 10. And what is the probability of getting 0 6s? So 0. Then we just use our graphics calculator for that. So we go into our distributions. I'm looking at binomial. Now, there's two options here. BPD, which is the binomial point distribution, and that's when you're looking for a specific value. So say you're just looking for one number. But if you're looking over a range of numbers, that's when you need to use the binomial cumulative distribution. For this one, since we're starting at 0, you can use either. The way the cumulative distribution works is it works from 0 all the way up until that number. So, for instance, if you wanted greater than 5, you'd have to work out your probability up to 4 and then do the complement, so 1 minus that probability to get your answer. But let's have a look at this first one. I'm just going to use BCD because it doesn't matter for this first one. Make sure it's in variable. And we just enter our numbers, so 1 6 0 10, and for this one we're going to write the probability of 1 6. And so for the probability of this one, it's going to be 0.1615. Alright, this time the die's been thrown 10 times. What's the probability of getting 0, 1, or 2 6s? So if you think about your distribution of your range of numbers, you're going from 0 to 10 here. We want from 0 up until 2. So we're talking about all of that range there. So 0, 1, and 2. So it's cumulative. So again, our probability remains 1 6. The number of trials is still 10 times. But our X this time is going to go up until 2. So let's go back. We're going to have the same information. We're just going to change X to 2. In that case, we get a probability of 0.7752. If a die is thrown 10 times, so 10, talking about 6s, getting the 6, so 1 6. What is the probability of getting 3 6s or more? Now we've just done this question here, which gives us up until 2 6s, so 0, 1, and 2. So 3 or more is just going to be the complement of that. So in this case, we'd still be typing 2 into our calculator because we're calculating everything up into 2, which is the same as the question above. And then from there, we're just going to go 1 minus that. So 0.2248. We kind of talked about this, that one's the complement of that one there. The mean and standard deviation. Now for the mean and standard deviation, you can see that the mean is just the number times the probability, and the standard deviation is calculated as so here. So mean equals NP, standard deviation, square root of NP times 1 minus P. The mean is just going to be 10 times 1 6, and the standard deviation is going to be the square root of 10 times 1 6 times 1 minus 1 6, which would just be 5 6. Cool. And then just to calculate those, so 10 times 6 is 5 over 3, or 1.67 times. And then the standard deviation should come out as that. And so that's 1.178 to 4 significant figures. Then for this next question, they both each throw a dice, calculate the probability that they both throw exactly 1 6. So it's 2 probability events. We need to find the probability of each, which will be the same, and then times those probabilities together because they're 2 separate events. So we're going to distributions, and we'll use binomial. Now, our P is still 1 6. Our N is 10 because they do it 10 times each. And the number we're interested in is 1. Now we're interested in it being exactly 1, so not including 0 as well. So we're talking about one specific number. So we're talking about the point distribution here. So BPD. So our X in this case is 1. Those numbers are the same from the previous question. So the probability of having X equal to 1 is equal to 0.323. And then the probability that they both throw exactly 1 is just going to be that probability squared. So 0.323 squared, which is this probability here. And then write down 4 reasons you think the binomial is appropriate for this. Well, if we were to look at Liz Snedden's page, there needs to be either just 2 possible outcomes. So in this case, we roll a 6 or we don't roll a 6. So that's one of the reasons. Yep. A second reason, the probability of success is constant. Yeah, each time I roll a die, the chance of me rolling a 6 is the same. We have specified the number of trials, which in this case has always been 10. And each event is independent of the other. Yeah, so me rolling the dice one time isn't going to affect the result on the other one. So those are the 4 kind of reasons why.